typical 1001 lab kit consists of 3 sheets of metal, 1 sheet of controller, wheels, gears, battery, and everything in between. And the final 2 boxes consist of motors, screws, threads, standoffs, spare sprockets, gears, and everything they might need to complete their robot. Unfortunately, due to COVID-19, we are not able to use these because all the students are off campus or remote, so we are not able to use these at the moment, but these are VEX V5 equipment that was sponsored. The current robot that's being used is this Romy robot, which is pretty cool because once they start using, they continue using it for the 2000s. This way they don't have to buy a second set of equipment, a second robot when they finish the first course and move on to the next level. The 2001 and 2002 teams used the same kit for their teams. So a 2001 team would have this box full of motors, sensors, tape measure, an ESP32, a lead acid battery, wires, and anything they might need, as well as a 4-bar kit. So this 3D printed 4-bar kit is only available for RB 2001 because it is incorporated in their lab curriculum. So after they're done with 2001, we remove these from their cubicles and they're not used. For 2002, the students only use this box. Since the class is more focused on sensing, we do have a lot of sensors. And if they need anything else to complete their final robot, they can always request it from odu.cs.wpi.edu, and then lab system will hand those to them that we require to be returned at the end of the term or purchased. Unfortunately, due to COVID, we are not able to use these kits, so the 2000 students also use this Romy robot, which is convenient because, like I said before, 1001 students purchase it beforehand, so they don't have to repurchase it. An example finished robot for 2001 would look like this. So you have a 4-bar, a gripper, motors, and then this is controlled with an ESP32. RB 3001, which is a manipulation course of the curriculum, uses a robotic arm that is 3D printed. We have a camera set up right here for image processing and a 3D printed robotic arm and a gripper and the controller. We use a checkered board and 4 bulbs to complete the challenge. So the checkered board is for calibration and visualize the movement of the robot, and the bulbs are used for image processing, sorting, and manipulation. Because it's so compact, every student is required to purchase one of these robots, especially if they're remote. They can build it by themselves at home, so they can easily participate in the labs. Each team member is required to purchase it, so everyone can work on their own while we're away from each other during COVID. In 3002 navigation course of the curriculum, the students are required to program a Turtlebot 3 using ROS and Python. The robot is supposed to navigate through a random maze and map it. So if you give it a specific coordinate to go to, it should be able to go there with ease and return back home. Usually we use these robots to program. However, due to COVID-19, we are not able to do that, so every student can just simply use the simulation. So they will use Gazebo and Arvis to simulate their robot and complete their challenge online. Currently, the lab setup is a little different due to COVID and the social distancing rules. But this is what a typical lab bench will look like. So we have a voltmeter, a multimeter, an oscilloscope, and a computer. Currently we have two. Because the iWaterCans lab is closed, we moved a few of the Linux computers here just so that the 3001 and 3002 students can easily access them. Due to COVID, we have a hand sanitizer and signs to reserve and make sure that our students are disinfecting their workspace before leaving the area. We have our big lab bench here. Usually, you are not allowed to reserve these at the moment due to COVID. However, in person, pre-COVID, students sit around here to get help from either each other or from our lab manager, Kevin Harrington, or the professors and essays. Each class has their own cubbies, so 2001 and 2002 will share these cubbies. Currently, they look pretty empty because we removed all the kids due to COVID. However, after COVID, they are again able to use these for these kids, and if they want to store their current roomies, they are allowed to do that. Every team has their own slot as so. So Team 5 and Team 6 share this one cubby. They can put their kids and their final or in progress robots here. The same goes for 1001. Because the 1001 kits are pretty large, we currently have shelves for them, so they can put their final or in progress robots on these shelves. Every team gets a place, and they can put their kits in these little cubbies. Like I said before, we removed them due to COVID to make sure that they are not contaminated by anything. This is what the typical 2001 lab field looks like at the moment. So the challenge is to create a 4-bar that would lift these panels from different heights and angles. Of course, the lab challenge changes from time to time, but this is what we have at the moment. And to make sure that every student gets to try on the field, we actually designed smaller versions of these just so that they can take these home and try their robot during COVID. We have two projectors right here. So the professor or Kevin Harrington will use this computer, or anyone can use their own laptop to connect to these and show their work. During the lab sessions, usually either Kevin or the professor will share their screen and show the students what they're supposed to do for this lab. Because the lab benches are here and here, everyone can easily see the screen by just turning around. We also have a microphone for the professors, just so that it's a little easier to hear them. On our lab whiteboards, we have a few informative posters, so we will have our lab schedule there no matter what. Because of COVID, we are not able to leave the lab unlocked while there isn't an SA or an LA present, so it is pretty crucial that the students are aware of this schedule. We have our lab rules. We have a couple posters of our lab staff, so lab assistants and essays. The reason we are doing this is just to make sure everyone knows each other, especially during COVID, because you don't see your student assistants that often. We want to make sure that at least they know their faces and they know who to ask for a specific kind of help. So we have how can student assistants help you, and how can lab assistants help you, because they do separate things. The whiteboards are not usually cleaned, just to make sure that the whiteboards are usually not wiped down, just to make sure that if someone has written an information, everyone has access to it. This is actually very crucial because during my time, we had one specific board dedicated to explain a function in the code, and everyone, including the professor, used that whiteboard. So we like to keep things not. As an example of the brainstorming, we do have the whiteboards as an area where the students can write anything and everything. So this is just an example of a 3,000 brainstorming session. We also, not at the moment, interestingly, but we do have a lot of drawn memes usually, just a way for the students to represent their feelings, and it's always funny to go around and look at those funny memes. A few other things we have on these bulletin boards is a representation of the ESP32, some GitHub cheat sheet comments, and our lab's bill of materials, just so that when they're returning back their kits, they can look at these posters to make it a little bit easier for them, especially for the names, because the names can be a little interesting. The same goes with the 2000 kit, and we do have a SI unit conversion sheet just to make it a little bit easier for the students. Although we give our students a lot of fundamental equipment, they still might need a few more to complete their final robots. So we have this back room that is only student ID accessible, but only the lab assistants and currently the SAs are allowed to open it, except for the manager, who's Kevin Harrington, and the professors. So we store all of our stock here in these cabinets. And students taking RBE classes or working on their MQPs can easily access this room by making an order on Odoo, and the lab assistants will give it to them. But they are expected to be returned at the end of the term, year, if it's an MQP, or be purchased from the lab. Currently it looks a little chaotic just because all the other lab kits are in here, but I promise it usually is so much neater than this. Due to the large capacity of the classes, it sometimes gets a little crowded in this lab, pre-COVID at least. So as a safety feature, we do have a garage door that opens up. This way the room is so much bigger and the airflow and the capacity is increased. We absolutely love this garage door, especially during COVID, just because the windows are not allowed to be opened. So we need some airflow going on, and we open this at the end of every session. We also have a fire extinguisher here, just in case someone needs it. We do not have any powered tools here, that's why we don't have any goggles or any safety equipment. That is strictly reserved to the makerspace, so the students can easily complete their quizzes on Canvas and go to the makerspace to use the power tools, the soldering iron, the saw, and anything they might need. They do require goggles. Currently, you need to go and ask them because they sanitize it between every use, but it's something you can do. We also have little cubbies in the makerspace if you want to store your personal project or your MQP.